a rock is thrown upward on the planet of Mars with a velocity of 10 meters per second, its height in meters t seconds later is given by y equals 10t minus 1.86t squared. Find the average velocity over the given time intervals 1, 2, 1, 1.5, 1, 1.1, 1, 1.01. We're given our slope of p and q, so this is our equation. Our slope c of the secant line, p and q, p2q. Here's our equation, stx minus sti, tx minus ti. And so what is our initial? Our initial is in time, so it's already given, it's 1. And what's our x is going to be changing. Our x is always changing, so this is our x. It's changing, times changing. Alright, so now all we have to do is plug in these intervals into our function. This is our function here. And so we put it in 2, put it in 1. This bottom, we have this right here, plug that in. And what does this all compute out to become? It becomes 4.42 divided by 1, that becomes 4.42 meters per second. And this is our average velocity of this given time interval. And then we do that again, we plug it all in, and it gives us 5.35 meters per second. And so let's work out this one really quick. So we use 10, because right here the function is 10 times 2, because it's 20. 1.86, 2 squared becomes 4. 10 times 1 is 10. 1.86 times 1 is 1.86. We subtract that, it becomes 8.14. This becomes negative. 4 times 1.86 becomes negative 7.44. 20 minus 7.44 gives us 12.56. Negative 8.14 gives us 4.42. Divided by 1, that gives us 4.42. And we do that for this following problem. Alright, so now we gotta find the time interval for this one. This is our time interval. Now we gotta find what the slope of the secant is for this one. My bad. So let's see. 1.1 minus s1. We already solved for this, so that's why I put 8.14 here, because we solved for it last time. And we do the following computation for solving it. Divide that by 0.1. It ends up being 6.094 meters per second. We do this next problem. Is that it's following. Divided by 0.01 ends up equaling 6.2614 meters per second. And then as following right here. And so I didn't mention earlier that the top part is change in position and the bottom part is time elapsed. So that's why these are the time intervals, and that's why it is being subtracted, because the time is getting closer and closer to our point of interest. So let's see right here. It says estimate the instantaneous velocity when t equals 1. And this is our point of interest, so it's t equals 1. And if we take a look at our average velocities right here, because these are all our average velocities, these orange numbers, when they're getting closer and closer to the number 1, as you could tell right here when we're subtracting it, we could make the assumption that it's getting closer and closer to 6.3. Right here this is 6, right here is 6.2, right here is 6.27. So we can only make the assumption that the instantaneous velocity is 6.3 meters per second. And so if we kept plugging in numbers and making the time elapse smaller, we would eventually get a number that looks like this. So this is our instantaneous velocity. If you enjoyed this video, please like this video, and it would help a lot if you would subscribe to this channel, because it will help me keep making content like this. If you have any questions or comments, please leave it down below from the description. And I can't wait to see you guys next time. Thank you, and bye.